So today's target is to calculate the change in enthalpy using average bond energies and determine whether the reaction is endothermic or exothermic. And to do this, you're going to need the table of energy bond energies, so make sure to have that while we're doing this problem. So this is the reaction that we'll be doing today, and to start we should do the Lewis dot structures of all of these. So Lewis dot structure of this is C, which has 4 electrons connected with H, which only has 1, and then you do O, which has 6 electrons, connect that, and H, and then you times whatever this number by 2 because there's 2 of these in the coefficients. And then to move on to O2, which is O2, which has each have 6 electrons, so these are going to be double bonded together, and then you just times that by 3. This is the reactance. Then you go over to CO2. Maybe C has 4 electrons, and O2 have 6 each, so it's going to be 2 double bonds. Six again. 2 double bonds, you do that times 2, plus HO2, O has 6 electrons again, and then H has only 1. You times that by 4. So we're now going to calculate the bond, single bonds, and what number they come out to. And there's 3 CH bonds, which is 413 times 3. 1 CO bond, which is just 358. And then 1 OH bond, which is 463. And we calculate that out. And that comes out as 2060. Then we go over to then we times that number by 2, which is 4210. And then we go over to O2, and it's a double bond, so you go down to the multiple bonds, and double bond O2 is 495, and then you times that by 3 because there's 3 in the coefficients, and 495 times 3 is 485, and then add that together with 4120, and it's 5,605, which is your broken bonds in the reactants. And then you go over to the product side, and you do CO2, and it'd be 2 double bonds of CO, which would be 799 twice times 2, and then that number by 2 again because there's 2 of the coefficients again. So 799 times 2 times 2, which is 3,196. Then you go over to the OH, and then it's 2 OH bonds, which would be 463 times 2, which is 926, and then you do that times 4 because the coefficient is 4 again. 926 times 4, which is 3704, and then you add that together with 3196, and you get 6,900. And to get your total change in enthalpy, which we'll do that right here, which would be reactants minus products, which would be 5,605 minus 6,900, which would be negative 1,295, which is your total change to enthalpy. And because it's negative, it would be an exothermic reaction. Thank you.